Imagine if the universe itself wasn't just a collection of stars and galaxies, but something far more profound. Imagine if it were a giant learning computer, constantly processing information and evolving. A neural network on a cosmic scale. A vast, interconnected web where every point is linked to every other, exchanging data and adapting in real time. This isn't just sci-fi. It's a concept that's starting to gain traction in the world of theoretical physics. Physicist Vitaly Vanchurin seriously proposes that reality, at its most fundamental level, is a vast neural network. He suggests that the very fabric of space and time might be woven from these interconnected nodes. Instead of relying on traditional concepts like particles or strings as the building blocks of reality, the universe, according to this idea, is made of countless interconnected nodes, like neurons in a brain, constantly interacting, communicating, and processing information. These nodes aren't static, they're dynamic, pulsing with energy and activity. The laws of physics, those seemingly immutable rules that govern everything from the smallest atom to the largest galaxy, might not be fundamental at all. Instead, they could be learned behaviors, emergent properties that the network has developed and refined over billions of years of cosmic evolution. Just as a baby's brain learns to make sense of the world through trial and error, forming connections and strengthening pathways, the universe in its infancy may have learned to create order from chaos, gradually establishing the rules that govern its behavior. Over vast stretches of time, this network settled into stable patterns, habits if you will, giving rise to the physical laws and the intricate structures we observe today, from galaxies to planets to the very atoms that make up our bodies. This theory, if proven, could potentially bridge the seemingly unbridgeable gap between general relativity, which governs the large-scale structure of the universe, and quantum mechanics, which describes the bizarre world of subatomic particles. It could unite them as different yet interconnected aspects of the same fundamental learning process, offering a single elegant explanation for the workings of the cosmos. Rather than viewing the universe as a static stage upon which events unfold, the neural network model paints a picture of an evolving, adaptive system, constantly learning and refining its understanding of itself. It's a radical idea, a true paradigm shift in our understanding of reality. The cosmos in this view is not just a collection of matter and energy, but a thinking, learning entity, a vast cosmic brain. If true, this revolutionary concept could finally explain why our best theories of physics, despite their individual successes, don't always agree, and why a unified theory of everything has remained so elusive. The universe in this view is not just a place, a container for all things. It's a process, a dynamic and ever-changing computation unfolding on a cosmic scale. And we, as conscious beings, are not merely observers, but an integral part of its ongoing computation, actively shaping and being shaped by this vast intelligent network. Calling the universe a neural network isn't just poetic, it's a profound analogy that hints at something deeper. It suggests that the cosmos itself might operate on principles similar to those we use in artificial intelligence. It's not merely a figure of speech, it's a scientific model, a framework for understanding how the universe might have evolved and organized itself. This model allows us to apply mathematical tools and computational thinking to the biggest questions in cosmology. In AI, neural networks learn by adjusting the strength of connections between artificial neurons. This process allows them to recognize patterns, make predictions, and even generate creative content. The goal is to optimize outcomes, to find the best possible configuration of connections that achieves a desired result. This optimization is driven by data and feedback, allowing the network to refine its performance over time. Vanchurin's theory takes this concept to a cosmic scale, suggesting that the universe's most basic units, nodes, the fundamental building blocks of reality, are like neurons, constantly exchanging signals and influencing each other. These interactions are not random. They are governed by underlying rules that drive the system towards equilibrium. The network learns by evolving toward greater stability, finding configurations that minimize energy and maximize order. This drive towards stability can also be described as a tendency to lower entropy, to reduce the amount of disorder in the system. The universe, in this view, is constantly seeking the path of least resistance, Physical laws, then, are not fixed commands handed down from some external source. Instead, they are the network's learned behaviors, the patterns of interaction that have emerged over vast stretches of cosmic time. The universe prefers simplicity and stability, favoring arrangements that are robust and resilient. It's constantly settling into patterns that work best, that allow it to maintain its structure and function efficiently. This perspective suggests the cosmos had a chaotic training phase, a period of intense experimentation and adjustment. It was a time before the laws of physics as we know them fully emerged, a period of raw potential and unfettered creativity. As the network stabilized, as the universe matured and found its footing, those laws became fixed, solidifying into the fundamental principles that govern the behavior of matter and energy. This offers a compelling explanation for why physical constants have their specific values, why the universe is fine-tuned for life. We're not in a static universe, a clockwork mechanism ticking away according to predetermined rules. Instead, we are inside a dynamic system, a living, breathing entity that is constantly evolving and adapting. It's a system that has learned its own rules through trial and error, through countless iterations of cosmic experimentation. The universe is its own operating system, a self-contained and self-regulating entity. It's running on a code it wrote itself, a set of instructions that have been refined and optimized over billions of years. Reality in this view is not a fixed and immutable entity, but the product of cosmic learning, a testament to the universe's ability to adapt, evolve, and create. This theory could explain quantum mechanics' weirdness. Quantum particles' fuzzy, probabilistic states might reflect the hidden activity of the network's nodes. Measuring a particle is like asking the network for a final answer. It collapses possibilities into one outcome. The observer effect becomes a natural result of the network's computation, not something mystical. Gravity, too, emerges from the network. Space and time are not pre-existing, but arise from the network's structure. Dense regions of connections create the geometry we perceive as gravity. Both quantum mechanics and general relativity could be different levels of the same system, microscopic and macroscopic behaviors of the network. This approach hints at a unified theory of quantum gravity. The universe's hardware and software are one and the same. Physics, then, is the study of a cosmic digital brain. To truly grasp the universe as a neural network, we need to explore one of the most mind-bending ideas in modern physics: holographic duality. Imagine if everything in our three-dimensional world, including you, me, and the stars, could be described by information encoded on a distant two-dimensional surface. This concept was born from the study of black holes. Physicists discovered that the information about everything that falls into a black hole isn't lost. It's stored on the event horizon, a two-dimensional boundary. It's as if the 3D contents are projected onto a cosmic screen. This led to the radical idea that our entire universe might work the same way. The holographic principle suggests that all the information in our 3D reality is actually encoded on a distant 2D boundary, like a cosmic hard drive storing the data for everything we see and experience. So how does this connect to the universe as a neural network? In both cases, reality emerges from the interactions of simple elements, whether they're nodes in a network or bits of information on a surface. The patterns and connections give rise to everything we know. Holographic duality gives us a powerful new way to think about the fabric of reality. It hints that space, time, and even gravity might be emergent, arising from deeper layers of information and computation, just like intelligence emerges from a neural network. This idea is more than just a mathematical trick. It's a bridge between quantum mechanics, gravity, and information theory, a possible key to unifying the laws of physics. If true, it means the universe is not just a place, but a process, a vast computation, projecting reality from the edge. To understand how the universe as a neural network might operate, we need to talk about Hamiltonian mechanics. In physics, the Hamiltonian is a mathematical function that describes the total energy of a system, both kinetic and potential. It's the engine that drives the evolution of physical systems over time. In the neural network model of the universe, the Hamiltonian can be thought of as the rulebook that determines how the network's nodes interact and evolve. Just as the Hamiltonian governs the motion of particles in classical and quantum mechanics, it also governs how information flows and changes within the cosmic network. This means the universe's learning and adaptation can be described using the same mathematical tools physicists use to predict the motion of planets or the behavior of atoms. In this way, Hamiltonian mechanics bridges the gap between traditional physics and the idea of a thinking, evolving universe. Holographic duality is still a frontier of science, but it's changing how we think about existence itself. It invites us to imagine reality as a grand illusion, one where the deepest truths are written not in the stars, but on the cosmic horizon. The world as a neural network unifies physics and information, offering a single framework for everything from quantum entanglement to gravity. It suggests reality is computable, and the universe's evolution could, in principle, be simulated. This idea opens new research paths, letting physicists use machine learning to probe the cosmos. But there are challenges. The theory is hard to test since the fundamental nodes are far beyond our reach. Without testable predictions, it risks remaining speculation. Critics also question its complexity. Does it just push the mystery one level deeper? Where did the network come from, and what governs its rules? Still, the idea is provocative. The universe as a learning machine, not just a collection of facts. It challenges us to rethink reality itself. For now, it's a beautiful hypothesis, one that might change everything if we can ever prove it. Thanks for watching. If you enjoyed this video, please like, comment, and subscribe to Innov8 Edge for more amazing science content. See you next time!